I think out of the three, UART is probably the simplest, and that's what usually gets implemented for GPS modules because you don't necessarily need any sort of control mechanism or like a call and response like SPI. So right now I have everything implemented for getting the GPS data. Actually, maybe I'll pull up real term. Yeah, this is it. As you can see, this isn't discernible data because it's a binary format. But it's basically being sent. It's being sent over serial or UART, and you would need a parser to be able to tell what this data means. Whereas with like NMEA, yeah, so that's what, let's see if I can pull up. So this guy right here is the GPS module, and most people, when they work with GPS, they use what's called the NMEA format. Yeah, this is a good site. And this is data that's clear text. So when you see the data coming like through here, you can actually see messages like this, and then you can do like you can basically parse it as a CSV to tell, like, you know, what time it is, the coordinates, how many satellites you have, things like that. But I've done a lot with NMEA before, but what it doesn't have, which is what I'm trying to achieve now, is it doesn't have the raw satellite data or receiver data that allows you to sort of make corrections after the fact as to the errors that are in the receiver's calculations. Because the receiver, you know, it just receives signals from the satellites, and then based on those signals, like the timing and the triangulation with other satellites, it tries to determine its position. But you know, there's a lot of factors that affect how accurate the GPS is. Yeah, exactly. So this data here contains information like the pseudo range and the, let's see. pseudo range and carrier phase, I believe. Yep. So yeah, this sort of goes over what I was sort of just glossing over. But let's see, carrier phase. Yeah. So it says carrier phase receivers are much more accurate than CA code receivers, which would be like, you know, the NMEA outputs. And yeah, these types of GPSs allow you to get data from, like, get atmospheric data from like NASA or NOAA that allow you to correct the signal that's coming in, and that allows you to achieve things like centimeter and even multimeter or millimeter accuracy. Multimeter. Yep. Oh yeah. So as I was saying, I have the GPS signal coming in to my RTOS system via, where is it? Via this GPS task. And then what it does is it puts it onto a queue that this SD task reads from. And every time it reads the message, it gets a chunk of data. It gets a chunk of data that it can chew on or pass on or whatever. And right now it's just toggling an LED every time it receives a message. But now I actually want to implement the right functionality. Yeah, the red board's my microcontroller. It's a Texas Instruments Launchpad Cortex M4. I think if you Google like TI or TM4C, that's the prefix. And as you can tell, it's it's just C. It's not like any of the goofy stuff that Arduino does. Yeah, actually, I think like I was talking to you before, and this is the same board. There's actually, let's see if I can pull this up. There's another launch pad I have here. I'll show it in the camera. You can tell it's slightly longer, and it's also faster. I forget by how much, but but yeah, this is another good board to use too. It has Ethernet, and I guess that's about it. But it's a fun board. Yeah, I've never worked with Arduino before. I just know that they have like their own IDE that you have to use and their own layer on top of the the hardware drivers. I like to just work on the bare metal. Which isn't to say, I mean, I think Arduino is cool and it's, allowed for a lot of creativity. But you won't be seeing anyone running Linux on an Arduino anytime soon. Or even like a launch pad. But does it have DMA? My obsession is with DMA. If we look at the the GPS task, yeah, and actually in college, I worked with Microchip's version of the ATmega 8-bit microcontroller, which was the PIC32, or not PIC32, PIC, the hell was it? 18F452, I think. Yep. Yeah, the PIC 18F452. This is a pretty good chip too. I think there's a reason why universities and stuff usually use this chip for teaching microcontrollers and assembly stuff. Like I learned stuff like debouncing and running 7-segment displays and stuff on this chip here. That sounds like an 877A. (16F). Yeah, I've never worked with a 16F before, except, yeah, not directly. Debouncing, that's when, like, when you push a button, basically the spring of the button causes the signal to go between 1 and 0 rapidly, which is what you don't want. It's an artifact of using mechanical switches to try and drive a digital system. So this is It's essentially a workaround that allows you to pause the processing of the switch signal so that you can wait for the bounce to settle out. And here I am reading the Arduino code. Yeah, so here's bounce delay. So yeah, it's essentially a state machine that goes from like not push to push, wait, debounce, and then after this debounce delay, then you can read the resulting signal. And then you can also do it for releasing the button, because some, in your code you might have, if this signal is 1, then do this, but you'd want to, but I think a better approach would be to set up a dual state, or a set of states where you push down and then you acknowledge that it's a 1, but you don't do that thing until you let the finger go, because then it allows you to sort of account for how long it takes the person to lift their finger. And I can't tell. Actually, I think that's what this code is doing. Oops. Yeah, so actually it's not doing it. Yeah, so this is just if your finger is pressed on the button, then the LED lights up. Otherwise, it turns off, which works for this, but for other situations, you might want it where you don't execute this function, whatever it is, until the person lifts their finger off the button. But anyway, that's the bouncing. Someone just made a comment on Reddit. I'll respond to them later, but they asked if there's a website for my project, and aside from my GitHub, not really. And I guess my application projects I don't really post anywhere anyway. Like this grader program, it's just sort of a suite of sensor acquisition. Like it has different tasks for getting accelerometer data and BMP. That's not gyro, barometric. Is that right? Yeah. Then IDG. It's been a while since I've looked at this. I believe IDG is, it's a gyro. Yeah, duh. And then yeah, HMC magnetometer. So I have separate tasks that each handle their own sensor, and then they forward the data to like either SD task or UART task. And basically, I'm recreating that in my NavSpark test, my GPS program. But yeah, to answer the question, I don't have like a site or anything for these projects. My GitHub has like the libraries, a lot of the libraries that I write, like the zero copy program, and this DMA memcopy program, and then the driver file for FATFS that I hacked up. This is on GitHub because I added things like DMA functionality. But those are just tools that I use for making programs like this. DMA, it stands for direct memory addressing, I think. And it basically allows you to move data around without needing the CPU to handle the data, because otherwise you need to loop through and then put the data into a register and then copy it over, and that takes up a lot of time and resources from the CPU that it could otherwise be using for other tasks. So DMA allows you to use a separate engine entirely, the DMA engine, for either transmitting or receiving data. And like I was saying, with the SD driver that I hacked, I added on this functionality so that you can essentially buffer up some data and transmit it to an SD card without the CPU. I mean, the CPU still has to set everything up, but once it enables the DMA channel, then it's on its own. And a few streams ago, I added this semaphore functionality. So it's essentially, this task is essentially sleeping while it waits for, where's my interrupt? Yeah, it's essentially sleeping while it waits for this interrupt to trigger. And once this interrupt triggers, then it gives the semaphore, which, as a function of the RTOS kernel, it wakes this task back up and then it can resume operation. And while this task is sleeping, I'm free to do other stuff in the kernel, running other tasks and stuff. And then conversely, for the GPS DMA functionality, I'm receiving blocks of data from the GPS module via DMA, and in this task I'm also waiting on a semaphore, which doesn't get triggered until these buffers are full. Now I'm also implementing, you can see this RX buff A and RX buff B. I'm also implementing ping pong functionality, or double buffering, and that allows me to work on this buffer while this buffer is filling up, so I don't run the risk of losing data because I've only got one buffer at a time. Yeah. So that's why you can see here, if service buffer A, send buffer A to the queue, or if buffer B, then send buffer B to the queue. But once it's on the queue, is it not monospace? Yep. I think maybe it's just because it's so small. Yeah, and I have a lot of spaces. Wait, I do want to see what font it is though. Yeah. Well, I do normally use monospace fonts, and this is set to Deja Vu. This is not. I text editors in block mode. I guess. I don't know. I think so. What's a good test? Yeah, I think it's monospace. But the text isn't too small, is it? I know I'm recording in 1080 and it looks fine in 1080, but some of the smaller resolutions I could imagine maybe being an issue. Yeah, I guess my assumption is that you don't run it in windowed, because I don't. I mean, I've got a 27-inch monitor, and I have to leave my IDE partially filling the entire monitor because it's too big otherwise. But yeah, I still assume that that it's full screen. Yeah. All right. So the point of this stream is supposed to be that I implement SD functionality. So what I'll do is I'll copy over. Actually, yeah, no, this should be fine. Copy this over. Oop. Oh, yes. Not just that though. It's interesting. It should be a symbolic link. Yeah. Yeah, so for this other project that I have, this one, like I was saying before, I don't upload my application projects to GitHub for whatever reason. And this particular file is its own GitHub repository. And so what I did here is so that I could, keep it in its own folder, so that Git didn't try to add all the project type stuff, is that this has, its own folder for GitHub, and then it has the same hierarchy as the actual project code. But as you can see, it's not in this project directory, but you can still see it in here, because I've done in Eclipse what is essentially a symbolic link. So you can see these linked resources, and this MMC file is its own linked resource, so that I can use it in the project even though it's not physically in this location. And I suppose I guess it doesn't really matter. It's in here now, so maybe I'll just keep it as is. But I still need to go in and make sure I have my include directories. So this guy. Okay, this is an issue because in my other project, the SD card was the only device using DMA. So what I did was I put this control table that's needed to store the settings for the DMA engine to retrieve when it does its transfers and stuff. I put this in the driver file itself, but since I'm also using DMA for the GPS UART, I actually have it set in here. So now I have to determine who's going to get this control table, and it's going to obviously be the main. But now I'm wondering, do I want to use DMA at all for this? Because that's not even the point of... I mean, it would be cool, I guess, just to have all the functionality. But now I have to try to remember what I need to do. I don't think I need to do anything, actually. I think once it's set, it's good to go. So I think something is wrong, obviously, with with getting these DMA functions, or at least one of the inputs to the DMA function is not available. Okay, yeah, so obviously we don't need this anymore. And it's actually good that I didn't use a symbolic link to that file, because I know I'm finding myself hacking it up. But this error, I've never seen this before. Expression must have a constant value. It's legit, right? Alright, so yeah, it's definitely something to do with this. Something tells me it doesn't like token stat, but why would that be? Alright, let's try. No. Nope. Um, am I? I don't think so. Oh, that's because, why is that? They are swapped based on whether they are receive or transmit. So this is the send SG list, and if we take a look at the struct entry, so this first number corresponds to the transfer count. Let's do the buffer itself. So each data buffer for an SD write is 512 bytes, and that corresponds to the transfer count. And then the item size is how big each individual block is. So they are, since the buffer is a uint 8, that's why I have a size of 8 here. And then likewise, the internal pointer for the DMA engine increments by 8 bits because that's how big each data size is. And let's see. Yeah, and since I need this function set sglist buff every time I want to reset the location of the buffer, I just set this as 0 here. So that's essentially a null pointer to this source address, which gets set later. But since it's going from a memory location in the microcontroller to the SD card, or in this case, it goes to the SPI engine, the SPI module, which then sends the data to the SD card. The SPI module has its own memory location similar to the buffer, but this memory location is just a register for where that module is at. So every time you send a chunk of data, or just a 1 byte of data, you send it to this register, and then the SPI module knows what to do with it. So that's why this has 4 or 5 arguments or whatever. And then this down here, since it's the receive, you essentially swap it. So you're receiving bytes from the SPI module, and then you're putting it into, let's use the buffer example again. Yeah, receiving bytes from the SPI module, and then putting it into the memory location on the microcontroller. And since the SPI module register, it's just one address, you don't increment the pointer to the register. So that should be okay. And this code works on the other program, so I don't know why it would be giving me errors here, unless it doesn't like the fact that I got rid of the control table. I don't know why that would be the case. Same thing. But it's definitely something wrong with this first struct entry. What if token stat becomes an array? It doesn't look like it's token stat that's doing it, but for some reason I'm convinced that it is. Just wanna allay my concerns. But no, that wasn't the issue. Yeah. Wow, there was other stuff using that token variable. But that's not the issue. What is the issue? So it's getting this URSTDIO. That was another concern. Alright, I'm gonna have to Google it. Actually, well, it's obviously a TI specific error. pain trying to parse this out because it's not a real function. It's just a macro for setting these configuration values. Yeah, probably. Well, actually, otherwise it would need to have an actual thing to pass in, I think. Let's see what's actually being modified here. Task. This corresponds to, yeah, this guy. And if it wasn't a macro, you'd have to create this object and then pass it into the function. Whereas with this, it's set at compile time and it's ready to go. And that's probably why it's a macro. This is really funky what they're doing here too. It must be some specific requirement of the DMA controller. You're like, I don't even know what you're doing. It's weird. I had to, oh actually, maybe I tried copying this directly at first, then I realized that I could just set the source pointer directly, so I just bypassed whatever the hell this was doing. That's nice. Well, we already established that it's not token stat that's messing it up. So it must be... Must be one of these registers. Alright. This is going to start adding null everywhere until it goes away. Wait. No. Alright. So it looks like it's ed made desc inc none. Why? Okay, JP, you might be right. Well, in the sense that line 128 was messed up, but why the hell was it messed up in the first place? Wait. Weird. Yeah, so this third item always corresponds to the source increment regardless of the address. And in this I have destination inc none, which for some reason never gave me that error in the other program. But here the compiler correctly failed. Okay. So this should actually be source inc none. Right. Yeah, because for the DMA receive, the destination address is still, is that right? The destination address is still the token stat. That's correct. It's just these never got switched around. Or I should say they did get switched around when they shouldn't have gotten switched around. That's probably a result of just copy pasting this entire line. Which, yeah, now I see is was not smart. Okay. Now everything is in order. And now I can get rid of this guy. I'll just comment it out for now. And then other, I think something else that use this. Yeah, this. Because this should be getting called in the main R2S function. Yep, right here. So it has its own control table. And this is preprocessor magic for the CCS compiler that allows me to store this control table to one specific address. So I don't need to do anything for pointing the stuff that I do in the driver file to that control table. So now everything compiles correctly, and I can move forward with initializing the SD driver, and then opening up a file, and then writing the SD data to the file. But since I've already written all that, I think I'm just going to copy it over. It's just a lot of boilerplate stuff. So the semaphores is used so the semaphores is used to communicate between the SD interrupt and the task itself. And I'm trying to remember task params.pc semaphores, why that wasn't just a global semaphore. Oh, right. Because the interrupt for the SD card is located within the driver itself. Down here. Yeah. So this is in the driver itself, and in order to share this int semaphore with the task, or with well, I guess the task isn't using the semaphore itself, never mind. But my idea was to initialize the semaphore in this main here, and then have it be used within this driver file here. Except it's being created in here. What the hell is that semaphore for? Alright, actually this semaphore isn't being used for anything. Never mind. So actually the semaphore that I use for the driver is fully contained in the driver itself, so I don't need to worry about that. What I do need to worry about though is whether or not I want to initialize all of my SD stuff. So if I look at this SD struct, like I need this fatfs structure that handles the current state of the FAT file system that I'm looking at. And then likewise the directory structure, file structure, And then this path stuff is for navigating directories and files. So this is all stuff that I need to have, and the question is whether I want to copy this structure over as well, or just do it all in the task itself. And already I'm leaning towards just copying it over because I don't really want to have to rewrite that either. This SDUtil also has a function that that auto increments a log file name. So if you've got an SD card with or if you've got a program that you want to, every time you turn it on, you want it to log to a new file, this SDUtil file has a function that scans the, where am I going? It scans the card itself and then finds the next number to increment to. So that's pretty handy. So now all I have to do is just include this SDUtil as well as the FATFS stuff within, so I won't do it in my main. Since I have this dedicated SD task, I'll just do it in here. And why did I just copy paste this over? Probably. Oh, this should actually be SD task. So now in here what I'll do is I will create one of these guys. Except up until now, I've been using this task parameters struct just for the queue buffer or queue array, I guess. And this is fine because both tasks use the queue and they both need the pointer to that queue. Whereas now what I want to do, it would be nice if I could go into SD task and actually create the SD struct here, allocate it, and then initialize it, and then put it into my task parameters, into this SD params pointer, so that I don't need to use the task stack to allocate that memory. However, it's bleeding the scope of who sees what, because the GPS task has no business looking at this SD struct, which it could in theory if I just threw it into this task params structure. So now I have to think, do I want to allocate it in the task? I guess if I still did do a malloc, it would just go onto the heap And based on my last stream, I've still got like 10k of memory in my heap. So that could work. So I'll just do that. So SD struct I'm just gonna look it up. They change it around so many times. They changed the API, I should say. In here, I think. Yes. I forget if I need to cast it or not. I might as well. Alright, so now in theory I have this params. Yeah, this test program is all over the map. I'm actually not even using... Well, it doesn't look like I even allocated. Or I did. But I'm not assigning... I'm not assigning the SD params to anything. Yeah, so this is just an unused variable that doesn't even get passed into the task. And the task, unlike what I wanted to do, or like what I didn't want to do before, it sets it up right in the task itself instead of allocating it. And that works, it's just not, it's not as clean. Because I want to use as little stack as possible inside of my task. So I think I'll just keep on with this method. Except I think I still need to... So this configure SD function is what I was talking about. This populate log file name. It goes through the directory structure and it looks at the next unused file index. But I'm trying to remember if it complains if I don't preset the file name like I'm doing here. Since I malloc it, it's just garbage data in there right now. I think what I probably want to do is do like a string copy. Hopefully, yes, I have it. So what is it? SD params log file name, and then 45.log, then Sterling 5.log. And I always forget, do I need to include the null? Because I usually use memcopy, because string copy isn't always available. I think the null is already handled. strlen, that returns everything but the null, right? Yeah. Excluding the terminating null byte. But I do want the terminating null byte. Oops. Well, this string, yeah, the string automatically gets a null. So I just have to increment by 1, and that should copy over the null as well. Oh boy. Oh, I'm using configure. Shoot. So for GPS task, I have this configure GPS. Which, what does it do again? Yeah, it configures the DMA stuff. So maybe what I should do is I should name this something a little smarter. And I should definitely rename this to something else. What should it be called? Not good at making names. Actually, this SD task in it, and then configure. Actually, I don't even need this because it's already handled by the driver. That's right. Now I still need an initializer task for the SPI module, which should be right here. So I'll need to copy this over. But as far as SD, I don't need a specific configurator. declared in the current scope. Oh, so it's actually grabbing the include located in TivaWare. So it's using TivaWare's own SD include. So I need to put a stop to that. But where would it be getting it from? So the software is defined right here. That's where DTI, TivaWare, yeah. So it only goes as far as TivaWare. Then you would need to call out third-party FATFS source, this guy o.h. And that should not be getting called anywhere. Oh, except for right here. Hey, what's up? So this is another question of how the hell did the other program run without complaining about this this redefinition? Because it's using the software root directory the same as the current program. And again, it's being defined before this FATFS. I mean, I might get away with it if I just go like that. Yeah. So it's okay now. I don't know why. Yeah, I guess this was calling out the TivaWare version, and then it was being loaded by the compiler or the preprocessor, and then these other guys were coming in and asking for the same thing. Is that really how I have it? Alright, invariably I need this in here so that I can have these definitions. But since they're already being included, I don't need them in here. Alright, now maybe I can check to see if I'm at least getting this struct, this ST-param struct allocated and set properly. I might as well pull this in since I need it anyway. That's all I should need, at least to get to this point. Or not. Oh, where's my disassembly? Alright, so now I'm looking up, since I have this little program counter saber, it allows me to look at what instruction line failed. 216A, it's up here somewhere. Yeah, it looks like one of the TI functions failed, which is actually what happened to me yesterday. I had to spend some time fixing that even before I started streaming. I should have actually streamed it though, because now I don't remember what was wrong with it originally. Why don't I first erase or okay. So it wasn't, I just had to reset the device. So now I can step through and make sure this SD params, so the SD params allocated correctly. And now once I step through this, I should see this log file name change, which it did. That's good. There's usually a blue light that blinks for the GPS receiver. I wonder why that isn't going anymore. Oh, actually, I think the blue light might correspond to whether or not it has a fix, a valid position, GPS position. And since I'm running it indoors, it's sort of spotty. So I actually shouldn't just automatically assume that it has a flashing blue light. But in any case, well, in any case, this guy should be blinking. Is it? Oh, I might have messed up the operation by pausing it. Where's that breakpoint? There we go. So now it's running with at least the SD struct added. So now I can go ahead and initialize the SD struct with this guy. And I really can't stay consistent on my naming stuff, but I tend to like underscore case better. And that just acts as a return status value for this function. If it failed, it returns a something not FR one of these guys, and then I can look at it later to see what failed. But presumably nothing will fail. All these should set correctly, and as long as the SD card is there, it should enumerate properly. So why don't I try that out? Or not. Oh, right. Now it's just a pointer rather than the struct itself, so I don't get the reference of it. See you, JP. Did I not? Oh. Int default handler. Oh, that means I didn't. I didn't put the SD interrupt handler in my interrupt vector. So what I need here, let's get rid of some of these tabs. So here I have this interrupt handler right here, and I need to add it into my interrupt vector over here under the SSI 0, I believe. Where's the SSI 1? No, it's 0. Here it is. Alright. Then I need to add this as well. Void SD handler. And that should correspond to what it actually is. Yeah, this. So now I shouldn't be hitting that default interrupt handler when I actually need the SD interrupt handler. I want to see if my SD struct initialized properly, so I'll just add this no op here. And I'll probably have to erase it, then turn it off. So what I'm looking for now, I guess I can look at the log file name. Okay, so the log file name returned 21.log, which means I have log files 0 through 20 currently on the card, and then this configure SD function properly iterated all those files and found that 21 was the next correct log to use, or file name, I should say. So that convinces me that it worked properly, because that's the last, that should be the last thing that this configure SD does. Yeah, fopen. Or, well, populate log file name changes the file name itself. But yeah, the fact that this is populated suggests that, or no, the file object. Yeah, here we go. Now what I can do is I can start writing. So what we'll do here is we can leave the LED, but the LED was just a placeholder for this f_write function. Then we'll replace this file write buffer with this guy, and then the mem buffer size becomes whatever was defined in, I think it's task parameters actually. Yeah, queue buff size. That's how large the buffer will be. Yep. Although, shoot. Well, I'm not guaranteeing that it'll be that size. Because right now the only thing that's being sent over the queue is the buffer itself, and that means in order to not write extraneous data, I have to ensure that buffer is filled every time I send it. What I should be doing is I should be sending a struct containing the buffer and an integer containing the size of the buffer, so that there's an allocation size for the buffer, but then I can fill it to whatever capacity I want, and then once I write it, I just use that size variable to determine how much to write here. And I already know it's not going to be 513 bytes because I just added an extra byte just to make sure I don't overflow. But what it actually is, if we go into GPS task, these buffs are actually 512 bytes, this RX buff size. So that's what I need to be using, but unfortunately I'm only sending the, well, it's fine for now, but eventually I want to be sending variable length buffers across the queue, and I need to restructure what goes into the queue itself so that I can read it on the other side. The other side meaning the SD task. So why don't I just put in 512 for now, knowing that that's how large the buffer has to be. But now that we've gotten to this point, I can add a breakpoint here so that we can look at all of the data in the buffer itself. Whoops. Bytes written. I think that's a 32-bit. It's just a short. Yeah, so this needs to change. Actually, I do still need the reference. Oh wait, I wanted to look at the buff value. Where is it? View as number format hex. Yeah, so here you can see all of the seemingly garbage data that's being sent by this GPS module in the buff itself, which is what we want, because we are now going to write it into the SD card. Actually, what I should have done yeah, I'm afraid that by stopping the operation, I messed up the state of the DMA. So it must be in some sort of error that I'm not accounting for. As long as I don't pause operation like this, it runs fine. But once I pause operation, anything can happen, really. But maybe what I'll do... Essentially, I'm just trying to prove that the file that we're writing to now will contain data once I go and read it later. But since I can't break here, I can't find out what the actual file name is. Yeah, maybe I'll just restart it. Did I restart it? So now essentially every time the red LED blinks, that means I've written a block of memory to the SD card. But I want to stop somewhere. So if we look at SD params, now the log file, so yeah, the last one was 21, now we're on 22. And it's been writing for whatever, the 30 seconds or so that I've been running the code. So I'll stop this, and I think it'll probably restart it and fail, but it's alright. Erase this. And what I'll do now is remove the SD card from the module itself, from the launchpad, and I will plug it into my SD reader. Now if we go and look at this 22 log file, open it with HXD, now we can see all of this data that was streaming in real time. Now we've captured it onto the SD card, and we can run it through a post processor. Just out of curiosity, I wanted to see if I could parse the file in RTKlib. But I don't exactly remember how to work with RTKlib. It's been a while. Well, I'm probably going to need to figure out how to properly parse. So this binary format is called SkyTrack, and I know RTKlib can handle it in real time, but I don't know if it can handle it in post. But if I launch something, oh, is this right? Yeah, I think this is right. So I'll close this down. And instead, yeah, so here you can define what binary format you want. And it doesn't even list NMEA because you can't you can't actually do anything with NMEA. But I am using SkyTrack, and the serial port I want is COM14 at 115200. Hopefully this won't like pinpoint my location. Alright, so you can see this RTK Navi program parsing the binary data, and then it's figuring out what satellites it's hitting and the signal strengths of those satellites, but it doesn't have a valid fix at the moment, which is why these are just like 0, 0. See what happens if I try plotting. Yeah, it still doesn't have a valid fix, so it won't even try plotting. But what you would see here is it would kind of populate this 2D graph with points of where it calculated my position to be. And if you did load a file for post-processing, it would load the entire set of data points for you to look at, and then you can go ahead with the post-processing operation, and it should basically take like the big set of points that you're getting and then narrow them down to like a smaller section. Pretty sure that's what it does. But yeah, I'm not even getting a fix inside right now, so I can't show you how it plots. But the takeaway from this is that it's turning this blob of binary data into something that you can actually look at, and if the location was there, you could see the location and you could see the plotting. And what else? So how this RTK works is that you have a rover which moves around for if you're doing like surveying or some sort of like moving positioning. And then you have a base station, which is non-moving. It just stays still. And the calculations for positioning are different based on whether it's a kinematic object or a moving object, or if it's a stationary object. And obviously the stationary object, you can make assumptions about the position, because the position by definition of it being stationary isn't supposed to change, and so you can have your own base station for this. You can also have an input correction from like what I was talking about before. There are commercial solutions exist, like how much do I want to go into that? Maybe I won't go into that. But essentially you have different data inputs, and they all get meshed together in this algorithm, which works to correct the position of the rover, because that's what you're aiming for is high precision GPS positioning. But I'm not quite there yet, because currently I'm only using a 1 receiver. And as I just found out, there isn't a way, unless there's some sort of SkyTrack file format that I don't know about. Currently it only handles SkyTrack in a real-time stream, and when I go to try to use this RTK post program, which is what you'd use, like, so you have your GPS file here, and then you have your optional base station. But I probably wouldn't use a base station if I'm going to use this. This stuff is SP3 and the SBAS file. Those two. One is a ground-based correction, the SBAS, and then the SPA or SP3 and the IONEX files come from like NASA or NOAA, and those correspond to actually SPS or SP3 I think is satellite information, and then IONEX is the atmospheric conditions. I could be wrong, but I'm pretty sure that's what that corresponds to. And those are used to correct for errors in the pseudo range and the carrier phase calculations, because like cloud cover and atmospheric conditions affect how much variance there is in those calculations. But since NASA is always collecting that information, they can do their own corrections on that data and get more precise values that you can go back and later use to correct the values that your GPS was sort of off in its corrections. But yeah, this is asking for a file format that I don't have. Ephemeris data, that's right. Yeah, I've worked with all these files in the past. I'll have to brush up on all that once I actually go to start processing this data. But what I wanted to show is that it can't properly parse this file. I need an OBS file, which is RTK convert. I wonder, maybe I can use this. Options. I think this is just the output options. Auto. So that assumes, I think, well, this makes me wonder if it actually did. Where does it go? Why don't I just set this right now? No. Okay. Well, I didn't get nothing, so that's good. So it actually did go ahead and convert convert the raw data that I was collecting, and it outputs it into this this universal format, this OBS format, which is a really wonky format. But as long as RTKlib is okay with it, then that's fine by me. Okay, cool. So I don't actually have to do any of my own parsing and processing. RTKlib handles that. And then the next step, now that I have this OBS file, would be to grab the SP3 and all this other stuff from like NASA's website. So I think NASA's files are, since they do their own smoothing on the files, I think they lag by anywhere from like 3 hours to a day to get a good data set for doing these corrections. It's 11:30 now. How long have I been streaming? 2 hours. So yeah, now that I'm writing successfully to file, like I said, I'm at the point where I can, if I had these files, I could go ahead and process them. But first, I actually need to get some valid data, which I'm not doing inside. So I will have to collect some data offline, and then for the next stream, I will come back and parse that data, and then I'll have these correction files from NASA once they're released, and then we can see how much accurate the output data will be after they get processed by RTKlib. But actually, this is cool. I'm surprised that it took this raw format and processed it into this OBS file. So yeah, other than that, I don't really have anything else that I want to do tonight. I'm at a pretty good stopping point. So I will go ahead with that plan, and then next stream I should have some good data that we can sort of find out what all this collecting data and stuff was about. So until next time.